Hi guys, this is Mrs. Homer, and today we're going to talk about metamorphic rocks. Make sure you have your notes out in front of you so you can check to make sure that you have all your blanks filled in. So the first thing we're going to talk about with metamorphic rocks is how they're formed, because that's basically how we define those three rock types. And metamorphic rocks are formed when any type of rock undergoes a change, and that change is from heat, pressure, chemical reactions deep within the Earth's crust. And so the words that are missing from your definition at the top are any and the word pressure, any and pressure. So metamorphic rocks have been changed. And so they take an original rock, a sedimentary, an igneous, or even other metamorphic rocks, and they change them by that heat, pressure, and chemical reactions. At the very bottom of your notes, you'll notice the characteristics of metamorphic rocks. So they often have layers, which we'll see in a minute, but they're rarely going to have fossils, pores, or holes. So we're not going to see those in metamorphic rocks as much. And the examples that we're going to notice throughout this presentation are going to include slate, marble, what we call gneiss, and schist. The ways that metamorphic rock can form are very different, but most of them are going to, of course, include some type of heat from magma deep within Earth's surface. So the first way that we can form a metamorphic rock is when this magma rises up and it passes the igneous, sedimentary, and other rocks under pressure. And that's going to begin the process of turning them into metamorphic rocks. So as magma rises through the Earth, the magma's heat can change rock into metamorphic rock. So that's just as easy as magma rising up. Next, we have collisions between the Earth's plates, so those tectonic plates, and that can generate heat as we push the rock down into the heat of the mantle. So it's getting really heated up as it's being pushed together and it's pushed down towards the mantle that is very hot. And then the other thing that can cause metamorphic rock are plate collisions when two of those tectonic plates collide. They can apply a large amount of pressure and cause that rock to change. This happens in the formation of mountains, which is why metamorphic rock is often found inside of mountains. And so 3 different ways, and there are obviously some more even, but these are 3 situations in which we can have heat or pressure or even chemical reactions changing rocks into metamorphic rocks. So how do we classify metamorphic rocks? We really classify them by the arrangement of grains. So remember, those grains are those small particles that make up the rock. And we are going to classify them based on the grains that make up the rock. And there's 2 basic categories of metamorphic rocks. The first one is called foliated. A foliated rock is going to have grains that are formed in either parallel layers or bands. So you can see in these rocks here that these layers are parallel. Even this one, even though it's wavy, they're still forming in parallel layers. This thin, flat layering is found in most metamorphic rock. So again, blanks here, it says grains are formed in either parallel layers or bands, which is your missing word. And then it says thin, flat, which is your missing word, layering found in most metamorphic rock. So a couple examples of this is granite. So we saw granite in class. If we take granite and we put it under pressure, it will form gneiss. And then you'll see these banded, foliated strips here. So this is a foliated metamorphic rock. Another example would be heat and pressure that change shale into slate. So here's shale, and under heat and pressure, it turns into slate. If we continue to add that pressure, we can either turn it into phyllite and schist. So again, these are some examples of metamorphic rocks that are foliated, because when you look at them, you're going to see this banding pattern. A non-foliated rock is going to be where grains are formed irregularly and they do not form layers. So quartzite is formed when the particles in sandstone recrystallize. So sandstone, which was layered, or you could say foliated, as a sedimentary rock, when it turns into quartzite as a metamorphic rock, you can see there's no bands, there's no regularity. This is an irregular crystals. Then you also have marble. So again, this marble has no banding. That's non-foliated. And this is happening when limestone is put under heat. It turns into that beautiful marble. So again, metamorphic rocks, they can either be foliated, which means banded or striped, or non-foliated, which is irregular without the layers. So that's it really for metamorphic rocks. So this is a bunch of rocks that we have looked at, and we can kind of classify them: our igneous rocks, our sedimentary rocks, and our metamorphic rocks. And so we'll practice remembering which rock is which and where they all go in one of our next activities. For now, please complete the Metamorphic Rock exit poll on Schoology. Hope you're having a great day, and I'll see you back tomorrow.